Alright, so we're still in 6.1, and we're going to talk about Euler's method. Now, Euler's method is one of those things that comes up a lot in the AP test. There's probably going to be at least one multiple choice, if not one for each section, and it could easily be multiple choice and free response question. A lot of times it happens on the non-calculator part, even though some fancy calculator programs that do Euler's method in half a second. So here's the idea with Euler's method. You have a slope field of some sort, and you're really just going to be using the point slope form of a line, and using that to take your slope field. So you got a slope field kind of that looks something like this. And what you do is you take any point that you have, so some point x naught y naught, and you take that point and you find the slope and you make a small line, and you only follow that line a little ways. And now what you're going to do is you're going to take the end of that line and find the slope of that point and create a line that goes just a little ways again. So we basically just take each of these little tick marks and follow it to the next spot, find the slope of that spot, use that point and that slope to find the next little line, and in the end you basically end up just following along the slope field and end up predicting where it will land. Now, a couple things. The longer you make these tick marks, the more rough it's going to be. If I make this tick mark like 3 units long, and then find the next tick mark, I'm eventually going to end up like way off mark. If I'm supposed to get here, I might end up here. So the distance that you take, we want it to be a small distance, but small is always a relative word. So how small do you want to make it? Well, the smaller the better, the more accurate your picture will become. And the smaller the distance, the more iterations you have to get there. So if you're trying to cover this much, x distance, and you're going by, I don't know, and if this is like, I don't know, 5 inches, and you're going by a millionth of an inch, it's going to take you a long time to get across that. But if you go by 2 inches increments, like it'll only take a couple, but you won't be as accurate. So there's a give and take, and it really depends on what type of computer you're using. If you're doing by hand, you don't want to do a lot of iterations because it gets really ugly really fast. So here's the deal. We're going to start with our point slope formula line. So y minus y1 equals our slope times x minus x1. Okay, so what do we know? We're going to have a point, x0 and y0, so here's we're going to plug those points in. They're going to find where we're getting to, but the change in x's is your small distance. So this x minus x1 is your change in x. That's your distance h. Okay, that's our small distance. This is our slope, which is generally going to be our slope field. So this is going to be some sort of function of x and y. H. You have in the y1, what we don't know is our new y value. We can tell you always the x value because you're going some small, and it's really a small x distance, not really a distance in like the x and y coordinate plane. We're just moving a small x. So if you start at 1, then we're going to go to like 1.1. So the distance of h would be 0.1. And so the only thing we don't know is our new y. So basically, y1 here is really like this is y0, and this is our new y1. So y1 is going to be our slope field, f of x comma y, times h plus our oy, our y naught, which is sometimes f of x of 0, depending on how you see this. So new y, your slope, times your distance, plus your oy value. All right, let's try to use that now. So when you do one of these problems, they're going to give you a point. They have to give you a point. They don't have to give you a step size. Sometimes they say, we know that f of 0 equals 1. Find f of, well, we want to find a step size of 0.1. So this would be generally going to be 0, 1. So if we make this little chart here, we got the order pair 0, 1. We're doing 5 steps, and we're using 0.1. So this is finding f of 0.5 using 5 steps. So these are the two ways you usually see this. So sometimes I'll give you a point and tell you step size, and we want to find the new value. Other times they tell you a point, and they say find this point using 5 steps. They could have said using 3 steps, which would be annoying considering 0.5 doesn't divide up evenly by 3's. So the x's we already know. We start at 0, and then the first iteration is going to be 0.1. The next iteration is going to be go like 0.2, 0.3, 0.4, and 0.5. What we've got to do is figure out what all the y's are. So the first y, if we use our little formula, is going to be our slope. Now our slope is given by this. Now we have to use our old point. So our slope is x minus y. So x minus y would be 0 minus 1, or negative 1, times our step size, which is 0.1, plus our old y value, which is 1. Okay, so at first this is not too bad. This is negative 0.1 plus 1, which would be just 0.9. Okay, so that's our y1. It's 0.9. Now, here's the thing. When we want y2, we have to rely on our old point. So our slope is not still negative 1. It is now x minus y here. It's 0.1 minus 0.9. That's my slope. Times my step size, which is still 0.1, plus my old value, which is now 0.9. Not 1, but now our new value of 0.9. So every time we do this, we ignore this and start to use our new value. Okay, so what do we get? Now, after a couple of iterations, this gets to be pretty tricky to do by hand. We get, well, negative 0.8 times 0.1, which would be 0.08 plus 0.9. So 0.9 minus 0.08 would be 0.82. So you can see that this gets pretty tricky without using the calculator. So let's set up the next one, but I don't even want to try to think about what that would be. So we'll set it up. So we got 0.2 and 0.82 so far. Now we still have 3 more to go. So our new one's going to be, well, our slope. Our slope is x minus y, and our x is 0.2 minus y, which is 0.82, times our step size, which is still 0.1, plus our old y value, which is now 0.82. So you can see you still do this by hand, and that's a negative 0.6 times 0.1. And so you can do this by hand, but after a couple iterations, it just gets more and more decimally as you go. So you find your new values, run it through until you get to 0.5. You can do this using your calculator pretty easily. If you notice, we're taking, well, it's a little bit trickier once you have the x's, because the x's have to change each time, and this value ends up creeping along. And there is ways of dealing with that, and especially if it's just y. And you can use the answer button here. So you can't just hit enter for this problem, but you can use the answer button for these. So let me show you what that looks like a little bit here. So my answer is 0.82, right? And so we got to do 0.2 minus 0.82 times 0.1 plus the 0.82, but using just the answer. Alright, so parentheses, 0.2 minus, sorry, I'll move this back into focus a little bit, the answer times our step size, which is 0.1, plus our old value, which is the answer. My last question. Okay, so there's my next one. Now, if I hit second enter again, I can bring this back up, and I really want to do the same thing again. The only problem is, I don't particularly want to do 0.2 anymore. I got to do my new x value. So my new x value is 0.3, and my new y value is the answer. So new x minus y, that's my slope field, times my step size plus my answer. Okay, so I got 0.3 comma 0.7122. And here's the thing that you also have to be careful about. It's actually not 0.3 comma 0.7122 like I said. It's now 0.4 comma 0.7122. And that's where having a little chart here is really, really helpful. When you're looking at this, it's kind of hard to say what's the x and what's the y. the x was 0.3, the y was 0.785. So I just need to do this one more time to get to 0.5. So I got to change this 0.3 to 0.4. Answer again, and I'll have it. Hit enter, and we've got our new value. So the estimated value would be 0.68098. So in this version, find f of 0.5, f of 0.5. Now you can't really say equals, is approximately 0.68098. Let's set up one more real quick. So we got our slope field, we got our points, we got a step size of 0.2, so we know we have 1, 1. So our new y value is our slope times our step size plus our old y value. So our new y value is our slope, which is this, so x plus 2y, so x plus 2y is 1 plus 2 times 1. The step size is 0.2. My old y value is 1, so plus 1. So 3 times 0.2 would be 0.6 plus 1 is 1.6. So we have a new x value of 1.2, sorry. We're starting at 1 and adding 0.2. And our new y value of 1.6. So I'll walk you through one more, and then you use the answer button thing I showed you a second ago to find the rest of them. Our new y value, so if this is y1 and this would be y2, I guess, would be our slope, which is our new x, which would be 1.2, plus our 2 times our new y, which is 1.6, times my step size, which is 0.2, plus my old y value would be 1.6. And you can figure it out or use your calculator to run it through, but that's the process. Once you have this, we'll have a 1.4 and whatever this answer works out to be. And then you have a 1.6 and whatever this new answer works out to be. So the last thing we got here is, this is actually an AP problem taken right off of one of the multiple choice questions here. This is 9 calculator, I believe. So this is, they're giving you a point, but again, they give it to you in a little bit of a different way. So this is the ordered pair 1, negative 3. There's no chart, so I'd suggest making a chart right away. And we want to find y of 2. So we're looking for 2 comma something, right? That's really what we're looking for. And we have step size of 0.5. It doesn't tell us how many steps, but if we make the little chart, x and y, we have 1, negative 3. And then we gotta go 1.5, right? Comma something, and then we get 2. So we really don't have to do 2 steps. We're gonna have to do a bunch. The 5 steps we were doing before is a little bit overkill. So we'll run through at least the first one, and then you can try the second one to see if you can get the answer. Alright, so our new y is our slope, so 2 times x, which is 1, plus y, which is negative 3. Times our step size, which is 0.5, plus our old y value, which is negative 3. Run that through, that's your answer here, and then you have to run it again with our new values, 2 times my x, which is, 1.5, plus the y value, which was the answer to this old equation, times our step size, which is 0.5, plus the answer to this equation here, and you will finally get your final answer. So that's the idea with the calculator, is you can run this through. And there's ways you can make the one go to 1.5. And if you're good at programming, you probably already have it in your mind how you can run that. So feel free to make programs for this, but a lot of times this is not in calculator, so might as well get used to doing it by hand. Expect to be able to do 2 by hand. If on my test you do 2 by hand and then the rest of the calculator is fine. If I made a non-calculator portion, you would have to be able to do at least 2. Okay?